Question number 31. In common emitter amplifier, the phase difference between the input signal voltage and the output signal voltage. Do you know that in case of common emitter amplifier, the output is 180 degree out of phase. The phase difference is equal to 180 degree, and that under radian is equal to pi radians. So the correct option is first option. Question number 32. The equivalent resistance of the circuit across the points A and B is assume diodes are ideal. These are four options. Now, if the diodes are ideal, then this resistance is 0 and this resistance also 0. Then you see the circuit reduces to, this is 2 ohm and this is 4 ohm, and the lower half, this is 4 ohm and this is 8 ohm, and across it is 5 ohm. In order to find the equivalent resistance between the point A and B, and look at this one, that if R1 by R2 is R3 by R4, it is a Wheatstone balanced condition. So this resistance is of no importance. Then your circuit reduces to 2 along with 4 in series, and in second this is 4 along with 8 in series, and they are in parallel, and if you solve, this become 4 plus 2 6, and this is 12, and in parallel the value will become equal to the product over the sum, so 6 multiplied by 12 over 6 plus 12, and that is equal to 4 ohm. So the only option is 4 ohm, the first answer. The question number 33, the dominant mechanism for the motion of the charge carrier in forward and reverse bias silicon PN junction is, these are four options. Now, dear student, remember this thing, that in PN junction, during the forward bias, the majority charge carrier move across, and this is called the diffusion. So in the forward bias, it is the diffusion. But in case of reverse bias, which give the leakage current, it is due to the drift of the minority carriers that the current is in the circuit. So look at the option. It is the diffusion in the forward bias and drift in the reverse bias. The correct option is option number 3. Question number 34. Pure silicon at 300 Kelvin has equal electrons and holes concentration 1.5 × 10⁻16 per meter cube. The doping by the indium holes concentration increases to 4.5 × 10⁻22 per meter cube. The number of free electrons per meter cube in the doped silicon. Now, dear student, you know that the square of the number density of pure semiconductor is equal to electron density into the holes density in case of doped conductor. Now, this is given 1.5 into 10⁻16 square, and it should be equal to the number density of electron into 4.5 10⁻22. So this will give the number density for the electrons 1.5 10⁻16 square divided by 4.5 into 10⁻22. So this is 2.25 into 10⁻32 divided by 4.5 into 10⁻22. So 1 by 2 10⁻10, that is equal to 5 into 10⁻9. So the correct option is the second option. Question number 35. The radius of the germanium nuclide is measured to be twice the radius of beryllium. The number of nucleons in germanium. Now, dear student, that radius of germanium is given equal to twice of the radius of the beryllium. Now, relation of the nucleus radius to the mass number is power 1 by 3. So in proportionality on both the side, I write that the radius of germanium to radius of beryllium is equal to 2, and I fill is equal to A germanium power 1 by 3 divided by A of the beryllium power 1 by 3. Now this A of beryllium is given 9, So A germanium power 1 by 3 divided by 9 power 1 by 3 is equal to 2. Now taking the cube on both sides, then A germanium divided by 9 will be equal to 2 cube. So A of germanium is equal to 8 into 9, which is equal to 72. The number of nuclei in germanium is 72. The answer is the first option.